Hello viewers, welcome to SciTech. And so today's video was requested by one of the viewer. She is doing her PhD from a reputed university. And then the topic for today is, so this is the research article that she was referring, and she is uh, facing difficulties in designing her own microfluidic chip. And based on the request, so this was the article that we have chosen. So it is advances in glioblastoma on a chip for therapy approaches. And to keep it general, so this video is just for educational purpose. And if you feel this is interesting, please share this. And also I request other viewers, you can also share me your microfluidic design or microfluidic channels which you face difficulty in designing on yourself. I can give you a brief idea or a representational view so that you can design on yourself. So this is how you can contact me. So you can just email me the requested design and the design which you want exactly, like design one on so and so paper, and this is like a clear view that gives me an insight that which I can target. Okay, so moving ahead from this paper that we are going to design a microfluidic chip for glioblastoma on a chip for therapy approaches. And if you see, the advantage of microfluidic design is always known forever, but we can have a clear idea again. The most complex devices showed intersection between different systems, allowing in vitro studies. So it is like mimicking the in vivo studies in vitro with major human genetic similarities. So it has the similarity that we can compare with the human body, and then it is reproducible, low in cost, and these are customizable platforms, obviously. Okay, so these are all the initial details that we are going to, and if you see, the design that we are going to do is pretty simple and complex. Both are involved in that. So actually, so this is the design that we are going to target today. So it is glioblastoma on a chip design. So if you see, there are 1, 2, 3, 4, 5 inlets, and similarly 5 outlets, and there is a intersection crossing from left to right or bottom to top. You can decide. So once you see this design, it looks pretty complex when you have this kind of curves. So it is common for a beginner or for someone who is enthusiastic to do the microfluidic channels, but they face difficulty in designing their own channels. So for them, it looks complex. So let's see this, how to design this complex chip in a simple way. Okay, so I'll divide this into 5 different units so that it is easy to understand. So first we will start with designing this inner circle, and followed by I'll explain how we can move ahead or move forward to do this all complex things. Let's go ahead. So now I'll open my SolidWorks design. So as I told in my previous videos also, it is always recommended to go to assembly because the user wants it to be 3D printed instead of soft lithography. The paper explains soft lithography, but the user is more interested in 3D printing this kind of devices. Okay, so let's begin. We can insert a new part, so we can rename it as first base. Let's select the front plane. Okay, so this now whatever dimensions I take is just for reference purpose, because I'm not going deep into the paper, I'm not copying the paper. It is just for educational, so I just take arbitrary dimensions. So let's consider this as let's say 30 mm, and this can be our regular 40, or we can increase it to 45 mm. Let's increase it to 25. Yeah. Okay, once the sketch is ready, so just Okay, so if you see, so I have done a mistake over here because I have just see, this is just for a, like, from the past viewers asking that they have some mistakes over there. So if you see, I have inserted a part, okay, and I have renamed it, but the sketch is not inside this part, it is outside this part. So it means that this is in the open space of assembly. Okay, so this mistake please avoid, and then if you do this, then you will not see the features to like extrude, or there are no 3D features you can do it, because it is a assembly designing, so you cannot do that. Okay, so best way is to exit this, and then we can delete this sketch. Okay, now just edit this part. Okay, so this part which we are just now created, inserted, edit this part. So inside this part now we will design it. Okay, so for that, so now choose the front plane of this part. Yeah, and then take a center rectangle. So this could be 25, and this can be 45. Right, click OK, and then go to features. Now extrude it. So this is like an initial base that you are forming, on which we will create the grooves or the channels. So we'll give it as 2 mm. So this is the initial one that we have already created. Now this is like we have created this base of 2 mm. Okay, so over which we'll groove these channels. Okay, again click on this face, just sketch on this face. Okay, so if you see, there is a circle initially, so let's give the dimensions of circle as 5 mm. It looks pretty big, 5 mm. So same like this paper, and if you observe, the pink or light pink color channels is having lower in dimension, the channel dimensions, than the outside dimensions. Okay, so for example, this blue, red, pink and yellow, these three have the similar channel dimensions. However, the outside two channels have the broader channel width when compared to these inner channels. Okay, we'll also do the same way. So here, this is ready. So we can have straight lines. Okay. So for example, we can have a dimension of 12 mm. So these are all arbitrary dimensions. You can change them anyway. So let's keep it 14 mm. 14 is also fine. Okay. Then we'll have the center lines. So this helps us in mirroring the entities. Okay, so now let's mirror the same way. This be over this, and similarly we can design another line. We can have the dimension as, so we still have space, so let's keep it as 10 mm. Yeah, and same way now we can mirror this entity over this line. Okay, done. So now this is ready. So channel is not ready, but however this is ready. Yeah. So next we do is offset entities. Okay, so before going that, we can create the inlets. So for example, this will keep it as the, like a standard 3D printing, we can go for 1.75 or 1.70 mm. So I prefer 1.70 mm is sufficient. And similarly we can do the same over here. So again, let's use the mirror. So now create the offset entities. So offset entities is basically for channels. So since we have seen that inner channels are lower in channel width when compared to the outer channels, so we do the same way. Considering this as for example, we can keep it as 0.25. Okay, so 0.25 mm is 250 microns, and then we can choose for bidirectional. So bidirectional, it gives this 0.25 into two sides, so it is 0.5 micron channel. So indirectly it is a 500 micron channel. And then internal, the line that we have drawn is not needed for us, so we can create a construction geometry of base geometry. It means the previously drawn line, and choosing this line will also give this. Okay, click OK. So once if you see, this has been done. Okay, so next thing is use the trim entities option over here. Choose to trim to closest. You can just remove. And then also here, so this is like a opening we are creating to this, I think, detection region. Right. Similarly we can do it here. Okay, so now this is ready. But if you see, I always recommend in my previous videos also that the sketch is underdefined now. So for example, if you see this blue color line, so this is the reason that sketch is underdefined. So unfortunately there is a small movement here. So if you see this, so this movement is happened unknowingly, so this results in your error in designing. So this you will notice after you complete all the designing. So this is a major deviation that I did so that we can visualize it, but the minor deviations can happen always. So just press Ctrl Z, and now try to see that, so this line is not horizontal, that is the reason it is moving. So let's do it horizontal. So once you did horizontal, now it is horizontally moving, right? So it means that it is not constrained in this axis. Okay, so simple, use the smart dimension, just give it 0.5. Okay, so once you given it, so see all the sketch is black and it is showing us fully defined here. So this is what is needed in all the designs. Okay, so now this is done. So it means that the inner part is done, and now let's do this one side part. Okay, this blue or this pink, this yellow, any one we can do, and then we can, since it is symmetric figure, we can just do the mirror, right? So to do that, press Ctrl 8 so that you have a proper view, normal view. Okay, so now let's take a circle. For example, we can use till here, and then let's see the dimension for it. So it is 9.72, so I can give it as 9 or 8 mm, since we need one more circle also out of it. Okay, let's give it as 9. So we have some space. Okay, so 9 mm I am giving it here. Right, so this is 9 mm. And then followed by we have channels connected to that. Okay, right. So what we can do now, simple thing. So for this line, we can choose the distance from this to the center line. Let's say we wanted to keep it as 3.5 mm. Okay, 3.5 mm. And then the channel height. So previous length was 15 mm. So this we can decrease it to 13.5. So we are just cutting down 1.5 mm from the previous. Okay, and then to this we can create an inlet. Give the dimension as same dimension 1.70. Okay, so now next thing is you just do the mirror entities. Choose this and this, and we have to mirror about the center line. So you can see this here, right? So everything is ready. So if you are feeling that this the dimension that we gave is in between this and this is around 3.5, right? So this 3.5 you can decrease it, let's say 3 mm. Yeah, 3 mm is fine. Okay, because from this channel, if you see, this line is far but the circle is close. Okay, so the next thing we do is use the trim entities option over here. We don't want this line internal, we don't want this, and also we don't want this too, right? And then we don't want this similar to this. Okay, so we just want is the shape of this. Yeah, perfect. Again, use the offset entities. Use this option. So it is same way, it is taking the similar dimensions of 0.5 mm. It is 500 micron channel we are creating. Click OK, and then we can just we can remove this. Okay, so these two circles are yellow because, and also we have to remove this. So these two circles are in blue because they are not being given constraints from any side of the chip. So for example, I am just constraining it. So see, with one constraint it turned out to black and it is again fully defined. Okay, so now the same design you can just mirror it. So simple way, just use the mirror entities. So you can choose Okay, and then copy over center line. So now this is ready, and then after that we can just trim this two portions. Okay, so if you see that this is giving this kind of error because see it is over dimensions, so we can try to delete one of this, so it is fine. So anyone, if you delete the red thing, it will become fine. So once it is done, so for normal understanding, so now this design is ready, right? So same way, so this is ready, and then we are left with the outer two things, outer two channels. So same way we'll design for one thing and then we'll mirror it. Yeah. So again Control 8. So now we'll go for a bigger circle. We can have the dimension as it is 14, so we can go to 14.5, right? 14.5. And now if you see in this, it has this curves. So don't be panicked that how this curves are there. If you see with this straight line, if you just assume that there is a straight line, and if you draw this, so it can be somewhere around 45 degrees of angle, right? So consider it's a straight line, and then you draw a line. Understanding, this is a straight line and then a line towards this. So it is like a straight line and a 45-degree line is there. There is a relation between these two. So for that, what we do, okay, so we can have a curve. Okay, so now we can have a line from here till here. Okay, and what we can do, we can have the dimension of this line and this center line. So this we can maintain as 45 degrees. Understanding? So this is 45 degrees now. Okay, so if you see, this is what I'm telling. This is a straight line and it's a 45-degree curve. Right. And similarly, we can choose the length of this. We can keep it as 14 mm. Okay, and we can have it is a bigger outlet. So we can have, so it was 1.75, so I'm just keeping it as 2.5. Now similarly we can just do the mirror of this and this about the center, right? So now we just need this curve, right? We just need this curve, not all this. So again, use the trim entities. So we don't need this, also this. Right. And also actually we don't need this also. Right. So we just need this. And if you see somewhere we might have missed, so just close the dimensions. Yeah, so see, we have missed one trim tool lines. Okay, so now this is there, and now we'll start giving the dimensions. So let it be 2.6. And then if you see, this one line is again in blue in color, so it is moving this direction. Okay, so Control Z, and then so there's already having, so we can fix this point and this line. Right, so now again it is fully defined. So but if you see when compared to the previous thing, right, in the previous design, so it is having this curve, right? So for that it's a simple thing, so use this fillet option. So let's make it smaller. Let's try this. Right, so this is working. So we can try to go a little high if it is working. Yeah, it is working. Right, so 2 mm is sufficient. Use a fillet, or you can decrease the fillet also, whatever, like depending on the design that you want. So once it is done, so you see, so this is what the outer channels are looking like. But since they are bigger in dimensions, so this is 0.5 or 500 micron that we have decided. So this we can give as 1. So to give 1, so it should be 0.5. So because it is 2-way. So once it is done, click OK, and then trim the unwanted portions. So I have a doubt that the channels, whether they are interacting each other or they are from under the plane. So to the viewers, if it is under the plane, let me know. We can do another video how to do the plane above and plane below the channels. So this we can do. So once it is done, and then mirror the entities. So we want this. So carefully select them. Right. And then copy about center line. Okay. And again we just have to remove this entities. Done. So this is how the complete micro channel, like the microfluidic channel, was there in this pattern. So this picture is a copy or a representation of this design. Okay, so once you have all this ready, go to features. So there are two things. So if you are planning to do this with soft lithography, then channels should be extruded out. But if you want to develop this by 3D printing, then channels should be extruded. So this video it was for 3D printing, so we'll extrude it. And we can extrude it to 1 mm or 0.5 mm depending on the printer capabilities. Okay, so once it is done, so this is how the chip look like. Okay, and then you can just use some features, fillets to the circle like this portions. But we can do this later or now. So I just wanted to do the channels, the outlets, and then we can do the filleting. Okay, that is more easy. So come out of the part, and then since it is 3D printing, we need a closure from the top so that the liquid is constrained inside. So create a new part, click on the screen, and then rename it as top. Okay. So initially I renamed the first as base, and the next is the top that we are going to design it. And now again the same way as I told, click on this and edit this part so that we can edit inside this inserted part. Okay, so now select this face, click sketch. So over this we are about to do the design. Okay. And now, so we need all the inlets over these spaces. So simple. Just do this. This I'm drawing because we have to create the hollow spaces also, so that we have to open an inlets also. Sorry, open this for the upper layer. So make sure always the design is fully constrained. It means that the design should not be in blue. That is how it's like a professional thing, that it should be always in black. And then we'll use the and draw the center line. And then mirror all of them. Okay, and then go back to features, extrude. So now if you extrude, it will come as a minor the opening to the top layer. So the top layer we can open it as 0.5 mm. It is 500 microns. So it is just to close, so that doesn't matter. This is how it comes, right? So on the top of it, again we create the outlines. So according to this manuscript or this review article, it is open. So there is nothing after this. But I always prefer to create the supportings to the tubings. So it can be like this. Right. So we can give the dimensions as 3 mm. So this can be again 3 mm. There should be an inner circle as well, right? I think for this it is better to have 3.5 mm because the wall thickness is low. So after printing it, there are high chances that it will be broken. Right. So it's done. We can use the center line options. Right, so we can mirror this, copy about, this, right? In a similar way, mirror it, this and this, both this. Right. In the same way, you can create another circle, another this, and for this. So 2.7. Okay, so now once these two are ready, so we can do is mirror again. So we can mirror this entity to the left. Okay, not this left. So to the left. Okay, and then mirror this to the bottom. Right, and similarly we can this copy to this, and next would be the leftover this thing. We'll just mirror it again. So now if you see all the connections that we want is ready, and then go to features. Now extrude them. So now extrude them to a height of 3 mm or 2 mm depending on the tube that you're using. So generally for silicon tubing or PTFE tubing we use we prefer to be 3 mm. Click OK. So now it is ready. So if you see now, once I edit the component, so this is how it looks. So internally if you see, so this is how the final design looks like. Right. So this is how the final design looks like. So this has the 5 inlets and 5 outlets and 2 cross connectors. Okay, so simple. It can be saved as the assembly file and save all the assemblies as internal things. And thank you for watching this video. So if you like the video, then please share, and also I request all the viewers to please share your complex designs or which you feel that it needs to be getting some help from me. So please share to me. The email address is already mentioned in the video. Okay, thank you for watching. Bye bye.